he introduced me. My name is Hannes. You can follow me on Twitter with that Twitter handle. You can tweet about this talk with PHPTour and at AFUP. Is that right? AFUP? Okay. So you can tweet about this. So as I am introduced, my name is Hannes, and I can describe myself in a couple of emoji characters. Sorry, can you see the screen? Maybe not. Okay. So a couple of emoji characters. I am Belgian, so I live in Ghent. I like to swim, cycle, and run, but not at the same day, so I don't do triathlons. And then I love to work with computers. Wait, the last one is not really an emoji character, right? No, it's actually the company logo. I work for a company called madewithlove.be. .com is pretty hard to get. So we work with a lot of PHP developers and JavaScript developers. We have one person in France, one person in Portugal, a couple of them are in Brazil and Canada. So we basically work remotely, and we're always open for more French people because French people love cheese. And I love cheese as well. So Made with Love, we do PHP and JavaScript. But that's enough about the company. Let's talk about code reviews. But first, let's outline what the code review really is. A code review is someone making changes and someone else approving them or signing them off before it goes to the next stage of whatever it may be. Could be a production environment, could be a build of an API documentation or something. Someone has to write it off. Doesn't matter who writes the code. Could be a non-technical person, could be some administrative people, and it doesn't really matter who writes off the code changes. Could be the CTO, could be a junior developer. Anyone can do it. So if you look at this chart, the left side is the one that the programmer does, the one that introduces the changes. The right side is the tasks of the person that is reviewing the code. So first you write some code as a programmer. You commit the changes in separate diffs. We call them diffs. So small changes to the code, and then someone else is going to review that. They are going to add some comments, ask some questions, or demand some changes. And then it turns back to the programmer, and he or she has to reply or add some more commits, and the circle goes on and on and on until the pull request is done, because that's what a code review is. It's reviewing a pull request. The person on the right side will approve it, and then it gets merged and built and whatever is your workflow. So if you do this iteration quickly, it starts to feel like pair programming, because you're at the same time reviewing and someone else on the other side of the world is adding more commits, and it goes on and on and on until someone can approve it. You can also do this alone, so you can review your own code changes even before you commit them. If you use git add -p, you will see the individual chunks in every single file before you stage them. So when you use git, you stage changes, you commit changes, and you push commits. But basically, doing your own code reviews feels like a dog that's walking itself. You can just cross the street and don't see that some car is coming. So please don't do that. Always find someone else, even someone working on a different project, to review your code. So why should we spend time on that? That's a good question. A lot of people ask that. So for the person that is making the code changes, it's useful because they can deliver better code by getting immediate feedback on their code, even before it goes to production. They also start to feel more responsible of their code. They want to make beautiful code that people will not make ugly comments about. So they start to feel more responsible about the features they are building. So you start to take more pride and more pride in the craft of coding. For a person that is reviewing the code, it's also useful. You can learn from even the most junior developer in your company. PHP has maybe 10,000 functions. I still learn new functions every single week. Just by doing code reviews, you still learn from PHP, even if your coding is reduced to less than 10% of your time. So yeah, that's also useful, but also because the person that is building the feature might not be in your company in 6 weeks' time, and you have to take over. So if a feature is being built and some commits are being pushed to master or merged into master, chances are you will have to deal with those changes later on. So you want the best code and the best optimal conditions to start developing those features as well when the other person is gone, or when the other person is on holiday or something, or some bug is introduced. So yeah, for the person that is reviewing the code, it's also useful because he or she might be working on the same features later on. And then we get to the management, and management thinks those people are the hardest to convince about code reviewing. But basically, by working together, you build a better team. Everyone learns from everyone. The most junior people learn from the lead devs, and vice versa. People are getting more aware of the features and how they are built, even if they didn't participate in building one feature. And the code just generally becomes more maintainable. If the client comes to you and they say, we want to change this feature, it's more easy to change because everyone knows how the feature is built, and the feature is built with more quality control. So yeah, your code base is better for the future. So let's talk about who should do what, right? The person that is making the code changes should first look at an issue. He or she may get an issue assigned, could be on Trello, could be on Jira, whatever is your workflow. Look at the issue, ask some questions about the issue. What is the purpose of this issue? Should I build a date picker? Should I build a slider? Should it be a simple drop down? Make some specs, right? Look at the feature that is that needs to be built. And make sure that you know every single detail about the feature. Maybe you can add some links to existing code there. So if a feature has already been partially built, you know where to adjust it. So you add some links there. This is useful because when you're going to a conference and someone else has to take over the issue, he or she doesn't have to redo the same background checking. They can just go to the issue and see, oh, this is where it needs to be changed. That's super useful. So yeah, look at the issue, add some links there, add some documentation. That's before you start coding, right? You need to do some analysis of the feature. So you're done with the analysis, and then you have to start writing code. What do you write first? Tests, right? So guilty. I don't always write tests first, but if you want to work in a test-driven environment, then you write the test first, and then you write some code changes, and then you make the tests pass. How do you do that? First you write the tests, you commit them, you push them to a separate branch. CI will run the tests and say, oh, this fails, and then you start proving that you can actually make the tests succeed. Could be any kind of test, could be a visual comparison of screenshots, could be anything. So yeah, you write some tests, you make some atomic commits. You rename a variable, or you refactor some class, or you add a new twig template or something. By doing this in separate commits, you will allow the person that is reviewing the code to step over single commits next to one commit to the next, to the next, to the next, to follow the same exact workflow or thinking that you did when you programmed it. So by using atomic commits, you will allow the person that is reviewing the code also to skip over separate commits like code style changes. If you run an automatic linter to fix your code, then they can skip over that, and they will know that there's no functional changes in that commit. So by using separate commits, atomic commits as we like to call them, you will be able to more easily review a big PR. And then you made the changes, you go to GitHub, you compare two branches, and then you see this screen. This is a big form called Open Pull Request Form. And there's a title, but below the title there's a big text area box. There's a reason why it's big. You should fill it with as much information as possible. A lot of people copy paste some title in there from the issue, and then they say open pull request. Done. That's not enough. That's not enough. You should add a lot of information there, like the link to the original issue, some description about what you did, some thinking logic, why you created this code this way. Add the changelog maybe, what has been added, a CLI command has been added, or an endpoint has been added, or maybe something has been removed. That you can put that in a changelog. So yeah, describe some decisions, describe some design patterns you used, and then you go to the right side of the form, and there's all sorts of things. You can assign someone to review it. You can assign someone else not to review it. I don't get why there's reviewers and assignees. Add some labels, milestones, whatever is in your workflow, fill it in. And then you have an open pull request. So you assign someone to review it, and then it's their job to do certain things or not to do certain things, right? As a reviewer, you should not first start renegotiating the issue. It's too late for that. The code has already been written, and you can call someone out for not asking enough questions on the issue if you think that it will not validate with QA or whatever. Then you can close the issue and say start again. Start renegotiating the issue. You should also not talk about code style. It's too late. You should have a code style config somewhere and have a Circle CI or a Travis CI or Jenkins built for that. If there's a code style, you should decide on that upfront before starting making pull requests, and just put it in the config file, and then there's no more discussion in your code reviews. There's just no point in discussing code style in code reviews. So basically everything that can be automated, checking for duplicated code, cyclomatic complexity, code style, whether a commit can or a branch can be merged. There's a GitHub says there's merge conflicts, so you don't have to check that. It's all automated. So everything that can be automated should not be the task of a reviewer. So basically, if there's some AI that can do reviews and check for stuff that we should check, then we're all out of jobs, and we can just let the AI do the programming. So yeah, don't do stuff that can be automated. But what you should do is read the full text area. Read everything that is written in there. Go to the assigned issue. Read the discussion there. Look at the naming of the variables. If you go to the code, if you look at the code itself, look at the naming of the variables. Is it clear? Is like a variable that starts with is that the boolean or is it something else? Thanks. Look at the naming of functions, classes, everything. Look at design patterns. Are they well executed? Is there some interface missing somewhere? No, stuff that AI can't do. Only people can do. Also, look at things that are not in the pull request. Things that are missing, like a missing migration or something that might break the build. Will the deploy fail? Something that's because something is missing. That's something you cannot see in the issue or in the PR, but you should look for or do some thinking. What is missing here? Can we improve this? Right? So when you're doing that, you can also use these buttons. Go to skip to the next commits and skip to the previous commit, so you can follow the same thinking as the person that has been doing the code changes. So when you're doing that, you should give some comments on the code, but it's very important to mind your language. Language is super important when giving a code review. Sometimes people write sentences like this: "Oh my God, I'm a big fan of your code." You might not want to. You might not want to make it this personal, for two reasons. People might start feeling like superheroes while they're not, but also because you might offend them. Why is there a crocodile here? Anyone knows? So crocodiles are one of the oldest creatures on the planet. They are alive for millions of years. Well, not the same crocodiles, but their offspring. there's a reason why they're this old, because they know how to attack someone when they are being attacked, right? It's called the reptile brain. We still inherit the same part of that brain. When we are attacked, we will attack back. So when someone tells you that you should not have implemented it this way, I am attacking you. I'm making it personal. So try to reverse stuff like that. Try to make it about me. I think maybe I would have done this differently. I'm not attacking you. I'm just giving my opinion, and I'm asking you, what do you think about this solution instead of yours, right? Instead of attacking someone's reptile brain, I'm giving a suggestion. So suggestions are super important. You can use words like maybe, or I would, or maybe I feel like, right? Instead of making it about you, make it about me. And then there's this technique. Anyone knows this? You should have noticed by now that I like emoji. This is actually a compound emoji of the hamburger and the pile of poo, and it's a shit sandwich, right? The shit sandwich is, I didn't invent this, but it's a feedback technique, a way of giving feedback to someone without hurting their feelings. So first you start off with a soft layer. You say something nice, like, for example, I know you've spent a lot of time on this and you've done a great job so far, but then you have to give the hard news, the feedback, the negative feedback. No one likes to do that. But do it suggestively. Don't attack them. Don't say, you have done this, or you could have done that better. Make it suggestive. For example, you can say, I think the way we are handling our Elasticsearch indexes can be better, improved, blah, blah, blah. And then you top it off with a soft bun to, yeah, so if you don't top it off, it's basically toast shit. So you need to top it off with something nice so that they can get back to work with a positive feeling. And you can, for example, say, but maybe if we work together with this guy who knows a lot about Elasticsearch, we can fix the indexing stuff and blah, 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 blah. So you basically start motivating them to fix the feedback that you put in the middle. So yeah, that's a feedback technique. I think I'm almost running out of time, so last but not least, when you're approving a pull request, you see something nice, feel free to give a thumbs up or a smiley face or a heart emoji or something. There's like 15 different boat emojis, so if something is ready to ship, give them the ship emoji or a ship GIF. I feel bad for the camera person. So at the end of a pull request, everything is approved, signed off. All checks have passed. Code style is good. Tests are passing, and everything can be merged automatically. There's no merge conflicts. The final question is, who should hit the green button in the bottom? Depends on your workflow, of course, but in our company, we are working with people in a totally different time zone. So when you hit the green button, you are responsible to fix the merge branch when something goes wrong. When deploy fails, you have to fix it. When the other guys or girls are sleeping, you have to fix it. One last tip, there's command line instructions. You can always check out the code locally and try it so that you know how it works and you know when something will fail. Right, wrapping up, use feedback sandwich, try to be considerate, don't attack someone, make it suggestive. Yeah, and go home and try these tips. Thank you.